But we don't have to take it till next week, right?
Yeah, it's the 3rd through the 5th.
Okay, right.
So Monday through Wednesday. Anyways. Okay, I'll start.
Okay.
Unless anyone objects.
No?
Okay. Question 2, which of the following variables is or are quantitative? Mark all that apply. And I just said the bottom one, the number of people in a randomly selected classroom on campus.
I wasn't sure about the 3 most common brands of cars found in the US because that could be quantitative if they did the numbers of it. But I don't know.
I know what you're saying.
But if we're just doing the brands, then that's not, I guess.
Yeah, I think I'm going to leave it like this, and then obviously we can turn it in and see if we're wrong or right. So
yeah, that sounds good. Okay. I can go next. This one, students in an introductory statistics class went to Albertsons, blah, blah, blah. Anyway, I chose, sorry, I don't feel like reading all of it.
okay.
I wasn't totally sure on this one, but I chose an observational study, the second one, because the students had no control over the present.
That's what I chose too.
Okay.
So I'm going to skip the questions at the top.
Okay.
But I picked it is not possible without the full data set.
That's what I said.
I said it would, the median would increase.
See, and I thought it would either increase or it's not possible to determine. And I kind of lean towards possible because we just don't have all the information.
Yeah, but if you have this outlier that's, I mean, obviously none of the other people are going to be 12. And you're increasing that to 21. It's got to increase at least microscopically. I don't know how many, I mean, out of 99 people.
Yeah.
It.
I think it would, yeah. That's why I wasn't sure what to put, because I agree that it would probably increase it. Most, because the mean is 21.2 or something. Yeah. I don't know.
And you've got a 12, which is like way lower than the other ones. Gotta increase it a little bit.
Yeah. Well, we can try that. We can try increase and.
Obviously I could be wrong, but okay.
I think it's one or the other. It's either increase or we can't tell.
Yeah. Okay, next one, let's see. Give your accurate, okay. What percentage of students will complete the exam in under 50 minutes? I said 2.5. Okay.
You said 2.5?
Yeah.
Yeah, I didn't do that right, but you're right. It would be 2.5. I had said 95, but that's obviously, but yeah, 2.5. Read the question right. Okay, so the next one, I'm looking for the 35th percentile of LSAT scores, and I said 154.6.
Okay, so tell me how you got that, because my brain wasn't working and I couldn't set it up right.
Hopefully I set it up right, but what I did was first I used the probability applet to determine what the 35th percentile is.
And it was 0.454, right?
I got 0.385. And then I did, like, it should be, I don't know if I used the right, after finding that, I did the value minus mean divided by standard deviation to get the z-score. So I put the z-score equals the value of 50.7 minus x divided by 10.2, and then just did the math. But if I got the 35 percentile wrong, then mine would be wrong.
Okay, so when you're coming up with a percentile, you're shading the middle, right? And then you put in your 0.35 at the top.
Are we supposed to shade the middle? Because when I did it, it popped up shading just one side. And when I put in the middle, I see it's 454. So if I did that wrong, then my math would be wrong.
So just from, so the reason I did it that way is because I put in the 0.95 for the, and I got this z-score 1.96.
Uh-huh.
And I know that that's
That's right.
for 0.95 for 95%.
So
And so I shaded the same area as I did for the 95%.
I probably did that wrong. So let me do the math really quick with the correct number and let you know.
What do you think, Savannah? Where are you at?
I'm making sure because I have 146.8.
And that could be right. I'm doing the math here really quick. Well, I got 146.0692, and it says to round to 1, so 146.1.
So would you get 146 what?
I got 146.1 because we're supposed to round to 1 decimal.
141, is that what you got?
146.1.
Hey, I'm wondering if I put this in wrong.
Okay, so tell me your equation again for getting the.
I use the equation z equals value minus mean divided by standard deviation. And I used the value 150.7. And I said we didn't know the x, the mean. I mean, the mean I put in is that's what we don't know.
Okay.
We
So
don't
then,
know what the z, and then I put 0.454 equals 150 minus, or wait, I should have done that backwards. X minus 150. Wait, it should be x minus 150.7 divided by 10.2. I don't know if that makes a difference, but. Well, if I do it not backwards, I actually got 155.3. Because we're looking for the value, not the mean. We have the mean, and I did it backwards. So it should be, yeah. So then you add.
close.
So then we divide 10 times 10.2, and then we get minus 150, add 150, yeah. Yeah, I'm going with 155.3.
Okay, my only problem with that is that we're looking for the 35th percentile, and the mean is 150. So it's going to be less than that.
Yeah.
That's what I had gotten when I filled it out. That's why I didn't answer this one, because I was like, that's so wrong.
So, yeah.
So I don't.
And maybe it's like not even the right equation. I mean, I'm not even sure I'm using the right equation.
But that was the same equation I used, but I felt like I was totally wrong, so I.
Yeah.
Yeah, it's the right equation. But
I just don't remember percentile.
So how did you get the 146.1?
I had accidentally flipped it, so I subtracted instead of adding.
See, because that sounds more right than the other way. So
It does.
Well, wouldn't we subtract in order to get the 35 percentile?
It would be a neg. See, initially I had put it as a negative, whatever my z-score was. In which case we would subtract, and then it would be the 146.
yeah, because it would be the negative z-score.
So yeah, well then it would put it at the 146 then.
Okay, so let's see. I'm going to do this again. Negative times 10. Okay. Yeah, 146.1.
Should we try that one? What do you
Let's
think?
try it. I don't know. Because I just did that z-score as a negative.
Yeah, and it seems like,
Because it's got to be on that negative side. I mean,
yeah.
because it's lower than the mean.
Yeah, let's try the
146.1.
Okay, so question 7, I put skewed right.
Yeah, that's what I put.
I totally agree. But then I was looking at an N2. They
Uh-huh.
could have no cancerous patients in 2 people. Do you know what I mean?
Yeah. This was this is one I felt like they were just trying to trick you on it
I
too.
feel like it was too. So,
Because
Because I-
it's right skewed, and if the sample size isn't 30 or larger, it's still going to be right skewed. Because if it was 30, it would be normal.
okay.
So usually, how I do on these ones, well, from what I've seen from the other ones, is if it says it's right skewed, but the sample size isn't large, it'll be.
Still right skewed.
Does that make sense? Unless I'm really confusing
Yeah.
myself, and that's not.
You just gave us such a small sample size that I just don't know how I could end up with.
Well, I would think it would either be skewed right or we cannot be sure, but
I agree, one or the other of those. So if it's not the skewed right, we'll put the count.
all right. Okay, so the next one, this is another one where I was so confused, but I put 2.236.
That's what I got.
Good.
Okay, so the next one, 9, what's the probability for the mean capacity of 50 randomly selected tanks will be greater than 8,540 gallons, 0.991.
That's what I have.
Wait, this is for number 9. You got 0.991.
Yeah.
I didn't know it. And I don't even remember, even though I just did it like an hour ago, how I got my answer.
Okay, so I said the 8,540 minus 8,544 divided by 12 divided by the square root of 50. And then I got my z-score. And then I stuck that into my probability applet and shaded to right, and it was 0.991.
Okay. Yeah. I think I shaded, what I did was I shaded to the left.
So since it's a greater than,
You're right. I missed, yeah. Okay. So I'd done the math right. I just shaded the wrong direction.
yeah.
Would be greater than, I should shade to the right.
Yeah.
Okay. Ugh. Okay, is it my turn again?
It's
I
mine.
think it's,
Okay.
Whoop.
yeah.
Okay, so for the question 10, I put the probability of a type 1 error.
Yeah.
I thought it was the probability of rejecting the null hypothesis, whether it's true or not.
If you go to the lesson review, there's a link to the index. And if you look up on the index, if you look up significance level on the index, it says, let me get back there. I went there and I just looked it up. There's an index that has everything, and now I can't remember where it went. Anyway, it said that it was the probability of a type 1 error on the level of significance. There it was. It says a number that is used to determine if the p-value is small enough to reject the null hypothesis. This is also the probability of committing a type 1 error.
But we're using it to determine the probability of rejecting the null, though.
Well, that's a, are you looking at the last one that says probability of rejecting it, whether it's true or not?
Yeah.
And I just don't know, because it says right in the definition of a type 1 error.
Okay, we'll try both. Because I looked at the lesson and it said rejecting the null, whether it's true or not.
It does say use to determine if it's small enough to reject the null, also committing a type 1, but isn't a type 1 error rejecting the null, whether it's true or not? Whether rejecting a null when you're not supposed to is type 1?
Rejecting the null with, yeah,
Rejecting a true null hypothesis is,
yeah,
and so honestly, it could be both answers. Again.
yeah, it could, yeah.
I hate this. It's awful.
No, seriously, my head felt like I was going to explode by the time I finished this stupid thing.
Oh, I know.
It's our last one.
Yay! I know, except the test is going to be just as bad. And this took me forever to do this.
I know, me too. And there were a couple that I didn't even finish that I was working on. I just couldn't even remember. Well, okay, we can try the probability of rejecting the null, whether it's true or not. Because that sounds like it encompasses parts of the answer.
It's one or the other. So
Yeah.
if it's not one, then it's the other. So
I mean, we can
you
try
try.
different ones and see.
What was that, Savannah?
We can try the different ones because we can take it twice. So
Yeah.
Okay, and then I'll do the next one, which my other least favorite thing, which the following describes the correct way to interpret a 95% confidence interval. And I said approximately 95% of all 95% confidence intervals that could be computed from the females, blah, 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 will contain the true mean height. The third one.
Yeah.
Yep.
But I think it's also, we are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
Yeah, they're
yeah,
both,
I had both of those.
they both, okay. Yeah, you're right.
Okay, not going to read this monster paragraph, but are the requirements for the use of a confidence interval met? Explain. And I said yes, the distribution of sample means is normal because the data are normal. And I wasn't sure about this, so what do you guys think?
That's what I have.
Okay, sounds good.
For the next question, I have 0.02. I think that's
Oh, it's I have 0.016.
Okay, sorry, I had to grab that really quick. For number 12, sorry, did you guys say yes, it's normal because the data are normal?
Yeah.
Okay, and then 13, you said you had what?
She had 0.02 and I had 0.016.
And I had 0.875. Okay, how did you guys do that? Because this might be one that I could not figure out.
I'm trying to remember. Let's see.
So this one we have would open in SPSS, right?
Yeah.
Rates of return, and then we're looking for the p-value, right?
Yes.
Yeah.
I did description variables. Wait, why? So how did you do it, Savannah? Because I
I
obviously don't know.
remember, because I did this last night, and I don't have my SPSS pulled up. Sometimes it's a hit or miss with that thing.
Yeah.
Okay, I'm trying to think which one I.
Analyze descriptive statistics, explore. I did explore, and we're looking for a p-value.
Okay, I might have done it wrong.
I don't even remember, which is just dumb.
Okay, because I think oh man.
So you said 0.002, Savannah?
Yes.
That actually sounds more like I don't know. It sounds more
Or,
right.
well, I have 0.02.
Oh, 0.02.
But I have point.
Do not remember. That compare means correlate data.
Okay, where do you find the p-value on?
In that, I don't remember even where I got my p-value.
Oh crap, I can't remember how to even put this in because I did find. Oh, I don't even remember how to do this.
I don't either. That's what's so frustrating.
Okay.
I get percent, mean confidence, median variance, standard deviation, mean maximum range. Estimator.
Okay, which one are we on? 15. Okay, so I put the negative 1.11 minus 0.95 divided by 6 divided by the square root of 39. And I came up with a z-score of negative 2.144. And when I plugged that in, I got a p-value of 0.016.
Okay. Let's see. I don't even remember how I found mine.
Except that I just ran it through again and my mean for my thing is, or my X whatever value should have been negative 1.107. So I don't know where I got the 1.11.
Now, where did you, when you did that, which direction did you highlight on the app? I figured out how I did it. I put in a one sample t-test and I got the T and put that in the applet. But for some reason, I don't even know why, I highlighted the middle and the far left and got 0.875. But this, what should...
Well, was your T negative?
My T was negative 1.152. So should I have highlighted just the far left?
Yeah.
Then I would have had 0.1247. If that's correct.
If your T value is negative, it should be smaller.
Yeah, and so then I would have highlighted just to the left of the line, which would have given me the p-score of 0.125 when you round.
Okay.
I don't know. That's just how I got my number.
0. No. 0. I'm gonna do it one more time with my new.
So would this one be one-tailed or two-tailed? Because there's also the SIG two-tailed. Of course, and that, if you divide it by 2, if it's just one-tailed, is 0.1285.
I think it's one tail because it's saying that we're trying to determine if it's worse than the performance of the S&P.
Okay, so then if it is this one sample t-test, then the level of significance, that was the p-score, wasn't it?
Is it a t-test? Or is it a...
Yeah, this said look for the p-value. But then it said the level of significance. I remember there was a time when we took the SIG and divided it by 2 if it was one-tailed. Is that this case? It actually comes pretty close to what I found based on the t-score on the one sample t-test. Because on this one, the level of the significance should be 129 when you round up versus the 125, which is what I got with the applet. But
okay, so you did a one sample t-test instead of the...
yeah, when I went in the program, I did analyze, compare means, one sample t-test. And that's what I came up with.
Okay, so the 2.257.
Yeah, and because that's for two tell, then I divided it by 2 and got
Okay.
0.129. But I could not remember this one at all.
Okay, I'm gonna remember my other one and then we'll put in the 0.129 because I ran it as a Z
Uh-huh.
instead of E. So
Yeah.
I don't know.
I don't remember what the difference between T and Z was. I thought T
I
was when we didn't
either.
know. Was there a significant difference?
I don't know. I don't know. My brain is mush. So
Well, let's try the 129 because I know we've done that in the past.
yeah.
So, all right, whose turn is it now for 14? Is it mine?
I have no idea.
Well, I'll go because it probably. I chose the second one down, dependent sampling. He needs to select couples for a sample, so whether a particular wife is included depends on whether her husband is included.
Yeah,
Yes.
I agree.
And yeah, okay.
Okay, so I probably did all of the p-value things wrong. So for this test, I got a p-value of 0.096.
That's what I have.
Okay, mine is, but you two got the same 0.096.
Yeah.
I'm gonna go with
Yeah.
your answer because I don't think I did them right either, and you two got the same answer, so we'll just go with that.
I'm like, wish I remembered how I did it though, because I'm like,
Corey,
Sure.
write down your answer though, so you don't. So if it's wrong, we can
Oh,
go
yeah.
through and figure out how you did it. So.
Oh man, this is just killing me.
I know. It's ridiculous.
for question 16, I put the first one no because the p-value was greater than the level of significance.
That's what I put, even though my question was wrong. My answer was different. I got the same. No. Oh, man.
Oh, and this is another one that I was like totally confused on. So.
Okay. So is it your turn or my turn?
It's yours.
Okay. I put yes, the distribution of mean differences is normal because the data have been determined to be normal. Third one down.
Okay, sounds good.
Okay. Then 18.
Okay, 18. I had the third one down. Null hypothesis is the difference it equals 0, and the alternative, the difference is not 0. Not equal.
What they equal each other and they do not equal each other because they wanted to know
When I
if
looked at the lesson, it said using the UD thing for the.
The third one down, is that what you said, Connie?
Yeah. Yeah.
Yeah, that's what I have. Is
the third one down.
equals and then does equal 0.
What lesson was that in? Because I didn't remember this.
That was I think the one that we just did.
It was.
If you know the lesson, I mean, I can look it up later.
I can tell you the lessons just a second if you give me a second. It was either 12 or 13.
Okay, thanks. I can look them up. Because obviously I did not remember that one. Okay.
Okay, the next one is I put the second one, 95% of all 95% confidence intervals actually contain the true mean.
That's what I put.
Okay, I didn't put that, but you're probably right. I put there is a 95% chance that the true mean is between -2.34 and 8.775.
I put the the 95 all 95 because it seems like when we went through this recently, that was the right answer, like last week or something.
Yeah.
And so that's why I chose 95 all 95, to be honest. So I don't know. Okay, this next one, number 20, I don't have an answer for because I could not for the life of me remember, and I just went on to the next one. The p equals 4/5. What is the smallest value of n that satisfies the requirements for normally distributed p?
So this one is the one where you were taking n times p is
Greater
less than or equal or greater than or equal to 10.
and 1
then
minus p.
n times 1 minus p is greater than or equal to 10.
So it would have been x or n times 4/5 equals 10.
So yeah. So it was actually 50 was the.
Okay, let me run the numbers real quick if you don't mind to make sure I'm doing this right.
Yeah, absolutely.
Okay, yeah, I got that. All right, thank you. I don't know why I had a brain freeze on that one today.
Because there's so much information.
My brain can't hold it all. Well, since I didn't have that,
So much. Holy cow.
I'll do the next one. And I said the second one down, yes, 40 times 0.250 is greater than 10.
So I did no because I did 40 times 0.0233 is less than 10. So the conditions are not satisfied, but I wasn't sure which of the numbers I was supposed to be using in my
Yeah. So, and I went off the 0.25, not the 0.233. And that also confused me.
I wasn't sure which number I was supposed to be going off of. So
What do you think, Savannah?
This one I'm not sure. I put the last one, the 40, though the conditions are not satisfied.
We probably have to check both if we're comparing, maybe. Are we comparing?
okay, so when he was, what are the conditions met? So the sample proportion will be, okay, so you determine the probability that he will be, I don't know, because your little brother has a batting average of that. You want to determine the probability that he will have a batting the next season. So are we minusing? What are we doing with those two numbers with each other?
I don't know, but I say let's try the no answer.
Okay.
Partly because none of the yes answers showed that both conditions were satisfied. So it makes me think the yes answer is not necessarily correct. Do you know what I'm saying?
Yeah, I do know what you mean. Yeah.
So
even though we don't know why for sure.
Okay.
Whatever.
Okay. Is it my turn? I don't know.
I think so. Sure.
Okay, so for this one, I put the last one, 51.2% of the game. Oh my gosh, I can't read that one. And the sample of the male chromosome.
That's what I put too.
Yeah. Okay, this is another one that I didn't do because my brain fried and I just went on to the next one. So
I had 0.099
what I have.
So
That's
how
what you
did you get that?
Okay, let me read it. 'Cause I can't remember.
I'm rereading it and to see if I can. So we want less than 3.
Oh, this one I used the Excel sheet, actually.
Oh, the Excel spreadsheet. I forgot all about that. Oh, that would make this so much easier.
Yeah, so that one I did use that. So I put in the 320 for the X, and there's 750. The null hypothesis is the 0.45, and I did less than.
Less than, yeah.
Yeah.
Okay, I'm pulling that up.
So,
All these things that I cannot remember. Okay, so X was 750. Okay, and you got
0.099.
okay. All right, so let me. Okay, so you put in X of 320, N of
750.
750.
Right.
Okay,
Null
perfect.
was 0.45, and then less than for the type of test.
Okay, great. I got the 0.0992. Okay. All right, I think it's my turn. I put 0.091.
That's what I have.
So I put, okay, so they had only shaded the area to the right of 1.334, but this is actually a two-tailed test because it's a not equal. So I doubled the 0.091 and I got the 0.182.
You're right. I should have read that better. This is why we do this together.
Oh my gosh. Hey, you guys, I won't be able to read for a couple minutes. My, something happened to my quiz. So I'm going to pull and hopefully it's safe.
As long as you've been saving each of them, it'll save it as you go.
Oh dear. Do you want us to wait?
We can wait.
Oh no, go ahead. We're on 24, right?
We're at,
Yeah, we
No,
just finished 20.
yeah, we just did 24.
We got 0.182.
Yeah, I'm pretty sure. Yeah, okay, yeah, it's on there, so we're good.
Oh,
Okay.
good.
Okay, so I'll do 25. Let's see, I said the bottom one, I said any N will do.
Well, let's see.
You
So
said
in
that
order for X
because
to be normal, doesn't N have to be greater than or equal to 30?
that's what I put. But did you say that because it says that it is that
Because
it,
the distribution is normal. And it's an X, not a probability.
Okay, yep.
all right, that makes sense. Okay. I can do 26. I chose the no because in at least one case, N times 1 minus P is less than 10.
That's what I did.
For 27, I have the second one. UD does not equal 0.
Yeah, me too.
Okay, yeah.
Okay, and then I wasn't totally positive of this one, but I put the second one, his actual weight loss was 5.5 pounds higher than his predicted weight loss.
That's what I put.
I put that too.
Okay.
That one was confusing. But, okay. For number 29, I put the third one down as percentage compliance goes up by 1%. On average, 5 pounds are lost in 3 months.
Yep,
That's what I did.
Okay, good.
For the question 30, I put the residuals are normally distributed. There's a linear relationship between x and y, and then the variance of error term is constant for all values of x.
Yeah.
That's what I got too. Okay, so for 31, I got 0.78.
Me too.
Yep, that's what I have.
Yay!
And then
Same.
for 32, I put linear with a fairly strong positive association.
Yeah, that's what I got.
And then for question 33, I put 17.09.
Oh, I'm not even close.
I got 115.64.
That's what I
But I'm
got
not
too.
100% sure if that was
On-
right. What did you have?
On what I think what you did, Savannah, is you put the things in the wrong independent versus dependent, because I had to switch it like a couple of times and I got a 17 answer when I had it wrong. So we're trying to determine the price of 14. So 14 should have been in dependent, whereas 90 would have been in.
In the independent, yeah.
And I had it wrong at 1.2 and got the 17. So that's what you did.
Okay. What was the other one?
So 115.64 is your y-intercept,
Yeah.
Okay.
and then your slope is 0.627.
Yeah, that's what I got. So yeah, on these, you just have to be really careful to pay attention.
Yeah, how it goes.
Yeah, dependent versus independent. Yeah.
So then for 35, I got 187.5.
Oh, and I got 241.
Okay.
Yeah, I have 241.
Okay, let me double check that again, because
Okay.
I don't remember, because I kept, anyway, because I did it the different ways because I couldn't remember. I don't know if I wrote down the right answer that I had. So I'm going to start over and just do this really quick.
Okay.
200 below.
Below the 90?
I put 200 below the 14.
Oh, okay.
Yeah.
It's below
I
the
don't see why it was wrong.
Yeah.
Oh my goodness. I got 240.979. And we round it up to 1, so would it be 241?
Yep.
Okay.
All right. I don't know if this is correct, but 36, I have 0.518.
That's what I got too.
0.518?
Yeah.
I'm way off of you guys. So let me see. The confidence level. Let me redo this. Got like 80. So we go to analyze. Oh, where are my notes on that one? There they are. Confidence level. Analyze regression linear. %, confidence level.
So you go into statistics and you check your confidence interval, 95%, and then okay, continue and okay.
And what answer did you say you got?
0.518.
Okay. So what I did was I took the answer from the constant, not the 90 days. That's what I did wrong, because I see the 0.518 right there. So I just put in the top row instead of the bottom.
Oh, yeah.
Okay. And then that makes the upper bound then 0.735?
Yeah.
Okay, great. Just reading the wrong line. Okay. Then my margin of error is going to be wrong, so I'm going to have to do that really quick.
So I got 0.109 for my margin of error.
Yeah, 0.109 is what I got.
Okay.
Okay. So whose turn is it?
I think it's Savannah's.
Okay.
Yeah, I think it's mine. Okay, so for 39, I have the first one.
So I put that it was the third one with the larger, with the beta, because it says the true linear regression.
And I put that B1 does not, I put the second one, B1 equals 0 and B1 does not equal 0. Because I was looking at something and it said, I had it written down that that was the hypothesis and the null was B1.
Yeah, it's B1. It's the second one. B1 does not equal.
Second one.
Yeah.
Yeah, I had that written in one of my notes, but I didn't have anything written next to it. I just put or no, I wrote it as beta 1 equals 0 and beta 1 does not equal 0.
Yeah, I think it's the bottom
The
one.
bigger B.
Yeah.
Read my handwriting. Yeah, I did beta 1. So
I think it's the bottom.
Let's
That's
go
what-
with that.
Yeah.
I think too. So
We
okay.
can try one other time. So, figure it out. Okay. I think, is it my turn? I don't know whose turn it is.
Sure.
Okay. Okay. The number 40, I got 11.509.
What I have.
Okay, I do not have that. Did I read the wrong line? Hopefully it's something simple as that. Because I have 6512.
So it's the next line down. It's the 90 days.
Yeah, I did it again. You're right. 11.509.
Yeah.
Gotta remember to read the correct lines. So then the p-value is the same anyway, 0.
0. Yeah.
Yep. For 42, I have reject the null. There is sufficient evidence to suggest that the slope of the true linear regression line does not equal 0. We conclude that there's a linear relationship between 14-day ticket prices and 90-day ticket prices.
That's what I
That's the
got.
third down.
Yeah, me too.
Yay. Okay, these ones I got a little confused.
I hate these.
So I probably got most of them wrong. So for 43, I did a one sample z-test, but it's probably wrong. So what did you guys get?
I have the one sample t-test.
T-test?
Yeah, I would say t-test as well.
Okay, sounds good.
For 44, 44, I have the one sample z-test for that one.
Okay, because I put one sample t-test for 44, but I wasn't really sure.
44, we know what the 0.03, so it would be z-test, right?
Yeah.
We know. And then 45.
But for our, but for the one above, we know what the grams, I don't know. Okay, sounds good.
I don't know. I mean, we don't know
I don't know.
what's going to happen when they when they have the new, I don't know.
I'm gonna miss most of these. That's just because I just don't.
I know. Okay, so then number 45, that's what we're on, right?
Yeah.
I said test of 1 proportion.
That's what I said too.
Oh, yay.
Woohoo!
$46. I have test of 2 proportions for that one.
That's what I have.
So I said the test of independence, the chi-square test of independence. Because we're trying to decide if being communicative or non-communicative is independent of divorce. But I wasn't sure. I don't know.
That makes sense, but at the same time, we're comparing the percentage of people who divorce and the percentage of.
Yeah, I wasn't sure. So you guys did 2 proportions?
But you know that does make sense though with the chi one. Now that I'm rereading it.
Because that's what I said first, and then I went back and said it was the other one. But I'm not. Let me look at my notes really quick. And
I think you might be right with the chi thing actually. I really don't know. Because I'm
gonna leave the chi. You guys put what you want, and we'll just see who.
okay.
One, right. So.
Yeah, that seems good to me. So then 47, I put linear regression.
Yeah, that one was the only straightforward one.
Okay, does someone want to submit?
I can. Okay, we got number 2 right, number 3 right, number 4 we missed. So it was probably is not possible to determine.
Okay.
So yeah. Number 5 is right. Number 6 was wrong.
Yeah, number 6.
What did we have for number 6?
146.1. Is that what you had?
Yep.
Yeah. That was the percentage, 35th.
That was that one that I didn't understand how to do it all.
I didn't either.
Okay, number 7 is right. Number 8 was right. Number 9 was right. And so number 10 was wrong. So it was the probability of a type 1 error.
Okay.
What about number 13?
Number 11 was right. 12 was right. 13 wrong.
Okay, what was 13? Yeah, I wasn't sure about that one.
Looks like we're gonna have to play with some of these and see what we can figure out.
Yeah.
I'll keep going. So 14 right, 15 right, 16 right, 17 right, 18 right, 19 right, 20 right, 21 right, 22 right, 23 right, 24 right, 25 was right, 26 was right, 27 was right, 28 was right, 29 was right, 30 was right, 31 right, 32 right, 33 right, 34 right, 35 right, 36 right, 37 right, 38 right, 39 right, 40 right, 41 right, 42 right, 43 right, 44 right, 45 right, 46 wrong. So it wasn't the cheat.
Well, then it must
So
be two proportions.
proportions, yeah. And then 47 right.
Okay. Okay, I have to run, so I'll just work on 10 and 13 on my own.
Okay.
I mean, not 10, 6 and 13. 'Cause kind of figured-
So we only got 3 wrong, right?
we got 4 wrong. Number
4 wrong?
4, number 6, number 10, and number 13. Is that right?
And then number 46, because it was
Oh, and 46. Sorry, I fixed that right away and didn't write it down.
Okay.
We actually got 5 wrong.
Okay.
So I'm gonna